So I'll get started. I think, yeah, thanks again. Thanks for the introduction. I think I can skip most of these slides. I just want to mention I'm relatively new to Microsoft Research. I just passed my 6-month mark. So some of the work I will mention today was I did as I was still at IBM Research. So this talk is largely based on this book chapter I wrote recently with my former colleague Kush Varshni around human-centered explainable AI. We gave a selected overview of recent HCI, human-computer interaction work, not just our work, but also from the broader community around this topic of explainable AI. And HCI work mostly focus on people's needs and their interaction with explainable AI. So let me start from the basic, what we mean by explainable AI. I think there are kind of two definitions going around. There is a narrow definition. I feel lots of this algorithmic work, they focus on this technique and method that makes a model's decision understandable by people. But if you think about the user experience, right, they're often interested in this holistic understanding. So anything that makes AI more understandable besides decision process, they may be also interested in the data, the function, the performance. So they will consider that as a part of the explainable AI. So AI is not just machine learning, but my own work and this talk, we're going to focus on explaining supervised machine learning. So chances are you've heard this term explainable AI or related term like interpretable machine learning, AI transparency a lot, right? Recently, both in academic work and also in public discussion. It's also in legislation, right? For example, in Europe, in GDPR, it requires that whenever there's an automated system, people have right to meaningful information about this logic of the decision. The backdrop of all this is, of course, AI is increasingly used in also high-stake domains like education, transportation, safety, security. So in those domains, without human scrutability, it can be dangerous, right? And also, users tend to be more cautious. Without understanding the AI system, they might not be able to trust it or want to adopt it. So that's why we're seeing lots of practitioner, technology creator are very motivated to tackle this problem of explainable AI. So what we're also seeing is really in the past 5-6 years, we're seeing lots of AI paper published on the topic, proposing various kinds of XAI algorithms. So at a scale of hundreds of paper published each year. One of the reasons we need many new algorithms is there exists in average setting, there exists in what we call performance explainability trade-off, right? On the one end, you have simpler intuitive model like decision tree, linear model, they're easy to understand, but they often not perform as well. But on the other end, you have popular deep neural network, big tree ensemble. They perform well, but they tend to be complex, opaque, not really human intuitive. So this kind of trade-off exists in average setting. I want to mention, not always the case, right? If you have a well-structured data set, a meaningful feature, you might not have that kind of problem. So with that, there are kind of hundreds, thousands of algorithms, but they generally fall into two camps. One is to provide directly explainable model, right? Where I mentioned like decision tree linear model, but you're seeing more recent algorithm work is also developing new algorithm that hope to break this trade-off. More sophisticated rule-based model or addictive model that perform better, but still preserve some of this directly interpretable intuitive property. On the other side, we have what's called post-hoc explainability. That's when you decide to use a black box model, say deep neural network, you need another set of algorithm to generate explanation. I'll just take one example. If you work in this area, you're probably very familiar with this algorithm called LIME. It's a very popular post hoc algorithm, right? What it does is it takes this black box model, so a neural network. It just look at the input and output of an instance. You want to explain why this model making this decision. So you look the input and output and also sample the neighboring instance, and you build a simpler model at a local region, for example, a linear model. Then you use that simpler model to explain the black box model's decision in the local region. And the form of explanation is what we call feature importance kind of explanation. This is to tell you why I'm making this decision because the instance has certain important features, right? So in a tabular data, it's the weights of the feature. In an image situation, it's the pixel or patches of the image you can highlight. And with text, you can highlight the keywords. So Lime is just one example, right? So there are many other kinds of post hoc explanation algorithm, generally fall into three categories. Besides this Lime is to explain a local decision. We also have global explanation, which is to explain the model logic, which often what they do is to approximate this complex black box model with some simpler model, for example, a decision tree or rule set to give you a high-level view of the model logic. And a third one that's very popular recently is counterfactual explanation. That is to tell you, given this input and output, how do I change the input, often minimum changes to get a different output, often the more desirable output, right? So the different kinds of algorithm is not the focus of this talk. If you're interested, I encourage you to check out this website where we have taught a course at Kai last year. In that deck, I gave more example demonstration of how different algorithms look like. So in another kind of recent emergence is also this kind of XAI toolkits, right? Open source toolkits. What they do is they're open code library that if you're a practitioner, you're a data scientist, you can plug in your own data set or your own model, and then you can leverage this state-of-art XAI algorithm, right? So at IBM, I worked one called AI Explainability 360. Microsoft has this version called interpretable, and many startups, other big company have their own version. So they're really making those emergent XAI algorithm more accessible now to practitioners. So I believe we're really at a cusp of we're going to see more real world XAI system, right? AI system that has explainability as an important component. Importantly, this AI system, they're going to serve many domain, different user group. They're also going to be built by practitioners, right? Data scientists, designer, product teams, not just working in a lab. So what I'm seeing this HCI work in this human-centered explainable AI work as work that bridge from this current reality of lots of XAI technique being developed to this future that we're going to see real world XAI system. And one way I kind of understand this space, I find it helpful is to take a step back to see this big collection of algorithm toolkits as a toolbox of XAI technique. Of course, there are incredibly interesting technical challenges, but at the end of the day, right, what practitioners need is a useful toolbox, and they also need to know how to use this toolbox effectively. So with this toolbox conceptualization, I summarize this human-centered HCI work. They're really doing three things to advance the field of explainable AI. One is to help navigate this toolbox, right? Understand users' explainable needs, drive technical choices, knowing when to use what tools. And second is to assess the toolbox, right, by conducting user studies, empirical studies, especially to uncover pitfalls, unintended consequences of current explanation algorithm, And with that, also to expand the toolbox, right? To understand where things fall short and inform new method, new conceptual framework for human compatible explainable AI. So let's start from this, how to navigate this toolbox, right? Hundreds of different algorithms. One place to start is to characterize the space of users' explainability needs. Multiple work trying to answer this question of who are the prototypical users of explainable AI. So I'm really glad that the field has moved beyond to the initial focus on supporting model developers, right? Lots of explainability algorithms started with this motivation of debugging model, understand the model better, why it falls short, right? There's also HCI work. I put some examples here. These are debugging tool interfaces that leverage explanation to help if you're a model developer to understand why this model is not working, where the bugs at, so and then you can go iteratively improve the model. So the field has kind of moved beyond this initial focus, right? One important use case is currently, lots of AI systems are performing the role of decision support, right? They're not completely automating the process, but they're assisting a human decision maker. Often the AI make a suggestion, and a human decision maker, for example, a doctor in this case, looking at a medical imaging AI, the doctor is the one making the final decision. And in this kind of use case, the decision maker, they frequently want explanation because they want to, one is to judge, is the AI making a reliable prediction? Can I rely on it? They also want to gain further insights, whether to make a better decision and also to determine follow-up action, like how do I devise this treatment plan? Other kinds of user group, one is impacted group, right? People who may not be directly interacting with the AI, but their life can be impacted. One case in point we often talk about is loan applicants, right? Their loan application may be rejected because there's the AI behind. They're not directly interacting with it, but their life can be critically impacted by this decision. So they may want explanation to seek recourse, even contact the AI. Another group is business owner or the administrator. They might want to assess the AI's capability, regulatory compliance, and determine whether they want to adopt AI, how they should adopt AI, things like that. Also, the regulatory body, right? They might want explanation to really audit for legal and ethical concerns such as fairness, safety, privacy, and so on. So having these prototypical users are really useful, a great starting point. But some recent HCI work has discussed that this persona is not enough. The granularity is not enough, right? Consider a decision maker, let's say that doctor, in the beginning onboarding stage versus when they see um, um, a prediction that they're inspecting, they may have different needs. They may want different kinds of explanation. So their explainability needs will also vary depending on their different objective at different usage points. So recent Kai paper by Suresh et al., they basically proposed to characterize this design space by both user objective and user knowledge. They cut cross to characterize this design space. In my own work, I have found that even user objective, the granularity might not be enough. And one perspective I've been taking, I find really helpful to think about people's expandability needs is by the kind of question they ask, right? A how question, a why question, a what if question will need different kinds of explanation. There was also social science literature basically saying people's explanatory goal can be represented by the kind of question they ask, right? Taking this objective of debugging model, which can be performed by developer or sometimes by domain experts, people may ask question. One is, what's the performance? Is the performance good enough? And how does the AI make a decision? What is the logic? How might it go wrong? They may also ask question of looking at some particular mistake and asking why the AI makes such mistake. So this different question needs different kinds of explanation to answer. So this shows that there's lots of nuances, right? People's question depending on their knowledge, the task they perform. So at the end of the day, right, it's also really important to have user-centered process to understand for specific application, even a specifically interaction, what kind of question, what kind of needs people have. So that has been the focus of my own work in the past couple of years. We're developing a user-centered design process that starts with understanding users' question and use that to drive the choice of algorithm, the design of this explainable AI user experience. I want to give you a quick overview. As you may notice, I always put the reference at bottom of the slides. So if you want to know the detail, I encourage you to check out the papers. Um, so where I started was 2 years ago after I was working on this AX360, this open source toolkit. I got very interested in this question of now we want to introduce this expandable AI algorithm to practitioner. But what is this design space of explainable AI user experience? So where I started, I went to interview designers to understand the design space. And I was also interested in what are some design challenges for a product team to think about explainable AI. So I adopted this perspective of using question to represent people's needs for explainability. So instead of getting into what these different kinds of algorithm, which designers might not be familiar with, we create this question card, represent different kinds of question, why question, how question, and we brought them to designers. We interviewed 20 designers working across 16 AI products around IBM. So we started with walking us through this AI system you work on. What are some common questions people ask for understanding this AI? And then we walk through each question cards and discuss whether they apply, why would people ask that question, in what kind of situation, what kind of answer they might expect. So by doing that kind of work, the two output we want to produce in that paper, again, the details are in the paper. One is to derive this high-level guideline in terms of user experience, right? If you want to answer input-related question, performance-related question, these are some high-level guidelines to think about. We also are interested in this gap, right? What kind of question emerge in real usage context of AI that cannot be well addressed by current XAI algorithm. So we discuss some opportunity for new method, new technique that's in the paper. And another contribution we try to make is to develop this XAI question bank. So we did this quote unquote designer sourcing of user questions. And then we look at those questions, we cluster similar question, and we develop this question bank that represent this common space of user questions or users' needs for AI explainability. We also organize this question by these 9 categories, right? We have data-related question, output-related, performance, how at a global level, why not, how to be that, how to still be this, what if. Then another set of work we did was we took those categories of question, then we map them to current XAI technique that can address those questions. We particularly focus on techniques that are available in current open source toolkits, right? AX360, interpretable. And by doing that mapping, we also derive this guideline in the middle columns, right? These are explanations types that can address those questions, and they also grounded in the current technical feasibility, right? So there are really two important core ideas here. One is we want to reframe the technical space. So instead of thinking about this algorithm is a feature importance, example-based, we want to map them to what kind of question, user question they can answer. So that will also encourage practitioner to foreground user question, user needs instead of technical feasibility. And another idea is we want to create these boundary objects, meaning that designer looking at this table, especially through user research, they understand what user question they have, why they ask certain questions. And a data scientist, a machine learning engineer look at the table. We also like provide URL links for this algorithm. Then they can look at the technical details. Then we really want the designers and data scientists to work together to identify what is this appropriate algorithm to use for the application they're developing. So what motivated me is also something I learned from that interview study is what really opened my eyes is some of those process-oriented challenges for practitioner. Designers are really keen to advocate for explainability, but they face some challenges. One is it's challenging for them to navigate this technical space, right? They're not training machine learning. It's hard to keep up with what is different kinds of XAI algorithm. And their task is really to find the right pairing between what's right for the user and what is available given the current technical algorithms or tools. There's also communication barrier, right? In AI product development, ideally, you want designers and data scientists to work together, but in the world we're currently in, often designers are brought in too late. And then it's hard for them to persuade the data scientist or engineer to change the model or implement another set of explainable AI algorithms. So it's hard for people to pay the technical debt. So with those challenges we observed, one thing we did is try to develop this question-driven XAI design process. While at IBM, I spent half a year also doing a lot of work, try to promote product teams to follow this design process. I want to just give you a quick overview. So we encourage the product teams to do it in 4 steps. The first step is to identify user question. This can be just a lightweight step in your initial user research, right? After defining the system, you ask the participants you are, for example, interviewing, given this AI system, what are some questions you might ask to understand it, to use it? You might want to collect those questions through multiple participants. And the second step is to analyze the question. You want to cluster them. You want to see which question you want to prioritize. And here you can use that question bank as a reference to help you do the clustering. And step 3 is where the designer and the data scientist should really sit down together, right? Look at the question, look at the prioritized question, and see what are the algorithms that can potentially address those questions. There, that mapping guide I just showed you can be used as a reference. And once they determine a set of candidate technique, right? Data scientists can work on implementing them. And the last step is for designers to start with creating a design that present those techniques. And we also encourage them to do it iteratively, right? You want to create a design, you want to think about whether the design address all these questions and what's behind this question. And if not, you want to iteratively improve the design and close the gap. Again, the details are in the paper, so we do show this actual use case. We follow this process and create this design. So this was a project I collaborated with teams in Watson Health. We're trying to develop this healthcare adverse event risk prediction system, meaning that, for example, during the discharge process, the AI can tell the doctor this patient might have high risk of unplanned hospitalization, and the doctor can decide if they want to do some special intervention. Um, And as you can see, we started with doing interviews with doctors and we gathered their question for this kind of system. And you can see the design we come up with at the end has a clear correspondence to the question we collected, right? We have this feature contribution, feature importance visualization to answer the why question. We have this counterfactual explanation, tell doctor what action they should focus on so that the patient's risk can be reduced. To answer this how to be that question. Also very interestingly, we observed that doctor really interested in data related question. The reason is they want to know if the data, training data aligns with their patient so they can trust the AI's performance. So we came up with this design of a pop-up window to show this data distribution among important demographic factors. So yeah, again, encourage you to read the paper for more details. So moving on to the next part. So I want to pick a few examples to also talk about this pitfall of existing XAI method, right? Lots of HCI empirical study does show explanation helps with understanding, but I want to pick a few pitfalls to kind of also show why we need to think about explanation more responsibly. What I mean by pitfall is empirical study find no conclusive evidence that explanation could help users achieve better task outcome, especially around this use case of decision support. We conducted a study a couple years ago that was published at FACT 2020, right? We used this semi-toy example of AI decision support of a data set of income prediction. So the AI look at a customer's profile and make a prediction whether this customer is in the high or low income bucket. And then we recruit participants, then they are making the final judgment whether this customer belongs to high or low income bucket. What we find that is in this decision support task, showing explanation versus not showing explanation, just telling people the prediction, actually reduce their decision accuracy somewhat. And if we zoom in the data, the reason is because for instances where the AI was making a wrong prediction compared to the ground truth label, when showing explanation, people are actually more likely to blindly follow the AI's prediction. So it actually leads to this unwarranted trust that people should not have when people should be cautious. That explanation actually lead people to increase this unwarranted trust. And we're not the only study finding this kind of observation. Some of my MSR colleagues, they did a study looking at this kind of explainable AI visualization tool to support data scientists to do debugging work. What they find is the evidence that this kind of tool can also lead to overconfidence that the model is ready for deployment when it is not. Some studies even find that placebo explanation without presenting actually useful information can increase people's trust. So this really points to a, a potential risk of showing explanation, right? That can lead to unwarranted trust and confidence. And that also suggests that there may be a blind spot in this current XAI work is there's a disconnect with how people actually engage with explanation cognitively. A classic theory in cognitive science is this dual processing theory. You may have read the book Thinking Fast and Slow by Kahneman. The basic idea is when people process information and make a judgment, they follow two separate processes. One is this system two thinking, that's also called slow thinking, is you carefully read the information, deliberate on the information, and you make a rational judgment. But more often than not, people actually follow the system one thinking, which is fast thinking, by invoking heuristics or rule of thumbs to make a quick judgment. So there's an underlying assumption in a lot of XAI work that they're only ideal user who will read every bit of information carefully and make a rational judgment. But in reality, users are actually more likely to resort to this system one thinking, and without carefully reading explanation, it might invoke a heuristic of being explainable, being able to generate explanation, meaning this is a more capable system. And that's why we're seeing this seeing explanation actually can lead to this overtrust and overconfidence of the AI. What is also very powerful with this dual process theory is they uh, help to predict when people are more likely to resort to system one heuristic thinking. That is when either people lack either ability or motivation, broadly defined, right? And that point to another kind of set of pitfall of current explainable AI system is that they can lead to inequality of experience. And empirical study already show that, right? Some study find that AI novices compared to AI experts, they have less performance gain from explanation. They also tend to have more illusory satisfaction. They believe that the explanation help them without actually helping them. Some study also show that people benefit less from explanation in cognitive resource constraint setting, right? Whether they have less time or they're overwhelmed by the decision task. In some of our own work, we show that even personality traits make a difference. We look at this personality trait called need for cognition, which generally reflect one's tendency to engage in cognitively demanding tasks and whether one just enjoy deep thinking. And we find that for people who score low in that profile, they actually show explanation actually decrease their satisfaction. So what they study really point out that explainable AI can lead to this inequality of experience. So how do we move forward from here, right? So in the paper we discuss a few paths forward, but here I want to just pick one. Important is we need to think about more cognitive compatible explainable AI. Some work already start looking at interventions, right? Not on the algorithm explanation side, but on the interface side. How do we have intervention to encourage people to have more deeper system two processing? This can be as simple as just slow people down, right? Think carefully or encourage people to make their own decision first before looking at the model's decision. We also need to really understand just what kind of heuristic are involved in the interaction with explainable AI, with AI in general, and we're seeing some recent work doing that. Do want to point out that heuristic is not a bad thing, right? It's an indispensable part of people's cognitive process. The important part is to identify what is an unwarranted heuristic and what are warranted heuristic we can even leverage, right? One feature you can think of is um, you may have a third party experts that inspect AI with explanation and they can provide some kind of endorsement. And for novices coming to use the system, that endorsement can trigger authority heuristic, and that is a warranted heuristic, meaning that this authority does lead to more trustworthy, more reliable AI. And we can even cultivate and leverage those heuristics, especially for people who lack this quote unquote ideal profile of ability and motivation. Another set of path when you think about is how do we develop a XAI that lower this cognitive workload, right? Whether from the design side, we can think about progressive disclosure, or at algorithm side, right? How do we optimize explanation, accuracy, detail, and also the cognitive workload? How do we find that balance? So all these directions really point out that there's a currently underdeveloped space of explanation communication, right? What this feature importance explanation, what they're doing is only devising explanation. And if you're thinking about how human explain why I'm doing this particular thing, I'm not giving you a complete causal chain. how I want to communicate is being selective. I'm going to pick something I think is more informative or more persuasive in some context and show you. So I think this communication part is something both as a technical challenge and a design challenge as a field we should tackle. More broadly, right, we need to not put explainability as a red herring, right? There are more important issues beyond explainability. At the end of the day, we shouldn't put this responsibility or burden on individual users to inspect AI. We need to think about the broader factors to make sure the AI is trustworthy, is reliable, without expecting everyone being able to understand explanation, right? An example I like to use is you would take a jump on airplane without understand how the plane actually works. That's because there is a whole safety culture around the airplane industry. There are government oversight, third-party oversight, and lots of industry process to ensure that. So we also need to think about human-centered AI beyond just explanation. So with that, I also want to conclude on like doing this work around explainability, right? Bridging from algorithms to user experience. What are some broader lessons we can think about in terms of human-centered AI? One is that we need to think about human-centered reframing of technical space, right? I believe human-centered AI is not just about design AI, evaluate AI with real human. It's also we need to fundamentally shift our view when we think about a technique. We need to think about what kind of user needs, what kind of user value they address in the downstream usage context. And that will also encourage practitioner to foreground understanding user needs. And also we need to have responsible development and use, right? When we have AI technique, we need to carefully examine their limitation and their pitfall and make that kind of information available to practitioner. We also want to expand practitioner toolbox, not just technical tool, but also design tool, whether it's design guidance or design method. And lastly, I think as HCI researcher, we really have a responsibility to engage with deployment context, understand people's need experience, and also bring that back into technical development, whether to change evaluation practice or inform more human compatible AI as frameworks. Those are important work to do. So with that, that's the end of my talk. I want to thank you for your attention, and I think we have some time to take questions. Thank you.